Okay, here we go with a demonstration of the plasma ball being controlled by the Spooky. Now I'm going to control the plasma ball manually with the Spooky. Anything that I do manually, you can also do with the Spooky 2 software or Spooky Central software, whatever you're calling it today. I have a splitter on channel 1 right where I'm pointing, only so I can show you the pulses that are going into the plasma ball. And channel 2 we're going to use as a gating function. Now Spooky has a gating function. It's in the advanced menu. I haven't actually did a video integrating the Spooky software on the screen yet, and that's something I've got to practice a little bit before I actually sit down and do a real world video. I'm sure it's nickel and dime. Take me about 10-15 minutes to figure out how to do it, capture the screen and so forth from the Spooky. But regardless of that, we're going to take the plasma ball and give you a demonstration. This is the one that I modified today, the hardware, and did a video on. I've tested it, so it works just beautifully. So the first thing we want to do is just turn it off. There's an on-off switch on it, and plug in our power supply. Now our power supply, you can see in the background, it's this guy right here that I'm pointing to with the green light on. And that green light, LED actually, it's a multicolor LED, and it'll turn red when the current maximum is drawn out of this 500 milliamp 5 volt power supply, or Warthog, or Vampire module, whatever you want to call it. It's just an AC to DC module. Low current, 500 milliamps can still cook the transistors in here at 5 volts if you turn up the duty cycle too high. I can't stress enough, don't ever go higher than 50% on the duty cycle. Just don't do it, because I put a heat sink on the transistor, which you did not see in the video, but this unit does have a heat sink on that power transistor that's used to actually energize the transformer and create the Birkeland currents. Just don't go over 50%, because I've gotten several plasma balls back because people cooked them. Oh, I didn't know I couldn't run it at 80%, 90%, or 100%. Just don't do that. Square wave is the best. Sine wave does not work as well as a square wave. Triangle and sawtooth waves, which are waves that the Spooky can generate, are not the optimum. Square wave is the optimum. Presently, for this presentation, I have it set up right now. I went in and made the adjustments. That's pretty simple. I have it set up right now. Primary channel is 10.528. Why not just 10 kilohertz? Because I'm going to walk this down to my favorite frequency, 528, and I just wanted to have that already dialed in after I get rid of the 10. Don't even try to follow what I'm saying there. The lower frequency, channel 2, I have set for just 1 hertz. That's not a practical frequency to use, I don't think. Maybe somebody has other thoughts. But it will gate the upper frequency of 10K roughly on and off at 1 hertz per second. Now in my video, $7 plasma ball resurfacing, I had 2 TED Talk videos there, and the second TED Talk video made it very clear that you do not want to have a continuous frequency being generated to kill. They didn't say about a continuous frequency for healing or for repairing or anything, but to kill, because they said that our cells in our body could be adversely affected if we just kept pounding them and never giving them a little rest. And that is probably why John White put the gating function in the Spooky software, so you could pulse and give your cells a rest from the from the onslaught, not that it's necessarily an onslaught, but from the oncoming remote waves, which are supposed to be scalar type in nature, or longitudinal, the same thing, it's an interchangeable word, or something from the hand grips, which give you electrical pulses. You pulse yourself, don't just keep grabbing, give yourself a continuous juiced up voltage at a specified frequency for some Hilda Clark type application or whatever. And the plasma ball follows the same rule. Now I started out making one channel plasma balls, and after watching that video and doing a little research, I am entirely in agreement with the TED Talk video, and I'm entirely in agreement with John White and providing a gating function. I'm going to demonstrate the gating function by using channel 2 of the Spooky here. You do not have to do that in software. In software, you can change the gating function and just use one channel, and you don't have to use the second channel for gating that this plasma ball is designed for. You can do it directly from the software. Probably we'll need another video software-wise to show you integrated with the Spooky software I'm talking about. Okay, so I plug in the power supply. I'm doing a lot of talking. I'm going to plug in the primary channel. Red is sort of my convention for primary, and I'm going to plug in the gating channel, and white is what comes with these cables, so that's the way I set it up. And I'm going to start the Spooky. It's already running, so I'm going to turn on the scope, and the Spooky is running at these pulses. These pulses are 20. They're duty cycle of 20%. So they're high 20% and off 80%. High 20%, and they're coming across roughly 10 kilohertz. If I turn on just channel 1 of the Spooky, just channel 1, return. Okay, I have just channel 1 on it. I was trying to get channel 2 off. It's off. Turn the Spooky on, not the Spooky, the plasma ball on. And this is firing right now. An electric field is coming off this at the rate of 10 kilohertz, roughly. It's 10 kilohertz, 10.5 kilohertz. That's even closer. And I can show you that by turning on dual channel and bringing my probe wherever it is, dangling on the floor, closer. And this probe right now is just in the air. It's receiving the electric field radiated from the plasma. And just to prove that, if I turn it off, you see the field. You don't see the probe receiving any energy from the air. Turn it back on, and now I've turned both of them on. I've got to turn number 2 off. So it's getting a continuous 10.5 hertz. I'm going to spread this out and show you the alignment. Here's the pulse, and here's the spike, the electric field spike coming off the plasma ball. And what you see is some harmonics in here. The higher you go, the less there is in harmonics. It's just something I discovered. The lower you go, the more there is in harmonics from a square wave. And they're always harmonics. They're always related to the primary. So they're not bad waves. Harmonics aren't bad waves. And harmonics have their advantage. They can help the process of whatever you're trying to do. Repair a cell or kill a cell. Whether it's a cancer cell or some virus or a paramecium, whatever it is. A little water flea swimming around. I have yet to do a video showing that. I do have the capability of doing it. I just haven't got around to it yet. So if I change the frequency of channel 1, I'll go in here and hit return channel 1 frequency. And you'll be able to see if by dialing it in, you can see I'm changing the plasma ball. And right now I'm at a frequency where there's only one harmonic for every primary, and the harmonic is roughly at 50% of the primary. So you'll see the second bump pretty close to the middle of the two primary, or three that are visual. And I'm going to go back to 10. Nothing special about 10. I just know that there's not going to be any damage done to me by playing around with 10. 10's one of the safe frequencies you can demonstrate and play with not worrying about receiving an electric field at such a frequency that might actually not be good for you, because there are a lot of frequencies that aren't good for you, just like there's a lot of frequencies that are good for you. So I don't really even need to hold this, just keep it close to the plasma ball. I also have a frequency meter here, and you can see it's pegged. I think, you got feel of view, try and kill the reflectivity. And you can see the meter is pegged right now to the right. If I turn it, that's it. I put my hand in the way, and you can see that I'm blocking the electric field. Hopefully you're getting, you're seeing the meter deflect. What's that tell you? It tells you that the body is absorbing the electric field. It's not getting through the hand. It's in the way of the sensor inside the tri-field meter. And I have the tri-field meter right now set for electric field. It's also a magnetic detection meter, and also a radio and a microwave. It's a multimeter. It's a nice little unit. They go for about $100 on the internet, maybe $110. I think that's pretty close to what I pay for it. I think I bought it from either Amazon, or I buy a lot from Amazon. Maybe I didn't. Regardless. All right, now I want to show you the gating function, and I have it turned on at 1 hertz. So if I turn on the gating, so what you're seeing now is that I'm gating the primary frequency on and off by a secondary frequency coming out of channel 2. And it's going on and off right now at approximately 1 hertz. My favorite gating frequency is Schumann's resonance. Schumann resonance is reported to be 7.83 hertz. So if I dial this up a little bit, I'll go to channel 2, go to frequency, and start dialing this up. You'll see the plasma ball start increasing. It's going on and off at the rate of 1 hertz a second. 50% duty cycle on the gating frequency. I can have other percentages, but I only have 50% right now on the gating channel 2. So as I turn up the frequency, it just went up to 3 hertz. Now it's doing 3 hertz a second. And the primary, the upper square waves, going into the plasma ball, making the plasma ball do its thing at the rate of roughly 10 kilohertz. And I can go all the way up to my favorite frequency, one of my favorites, not my favorites. Right now I'm at 7. I'm going to put that at 7.8. And one more, 7.83. So you can see the plasma ball flashing at the rate of 7.83 seconds. It's gating a a primary frequency of 10 kilohertz or 10.5 kilohertz, whatever. And you can do this with any of the right frequencies, or the Hilda-Clark frequencies, wherever you're deriving your frequencies from. You can gate them at any frequency you want, and that's almost the conclusion of this presentation. If you go back to the video, the second TED Talk video on $7 plasma ball resurfacing within the Spooky Forum blogs, you'll notice that in that second TED Talk, it was mentioned that the 11th harmonic was found to be an extremely viable harmonic for killing certain pathogens. How they discovered the 11th harmonic, I have no idea. But you can do it. So you can take the 11th subharmonic of your primary and use that as a gating frequency. Or you can take a lower frequency and up it to 11 harmonics higher, the 11th harmonic above, and get the same effect. You always want your gating frequency to be the slower frequency, and your primary frequency to be your higher frequency. So now, a couple of quick things I want to point out before I close this video off. One is that I'm going to go to channel 1, which is the primary frequency, and I'm going to change the duty cycle. Channel 1. Okay, I'm at duty cycle. Right now it's at 20% duty cycle. And you can see the power being zapped from the power supply. Now, I don't know if you can see it, but that's not a solid red. That's a red with a little bit of green in it. That's a multicolored LED in this particular power module. And what that is saying that 50% of the time I am drawing pretty much as I can out of this little module. And the other 50% of the time I'm not drawing anything, and it's being reflected and seeing a green, meaning, hey, you're not even touching, you're not drawing any current, and red, you're drawing the max current. That could be a nice indicator because I have been finding most of the 500 milliamp 5-volt power modules that I recommend for this. Most of them have an LED monitoring light, but they're not all dual. A lot of them are just a single colored monitoring light telling you that you're drawing more or less current by brightness. The LED will get weaker or stronger depending on how much you're sucking out of the unit. So I'm going to change this down to a lower percentage duty cycle. And you'll just notice that the plasma ball gets a little bit lighter. Now I've turned it way down, so I'm not even getting the Birkeland currents. I've got it down to 12%, and I'm still generating Birkeland currents. I'm going to start going the other way, and you can see the Birkeland currents get a little stronger. I'm at 20% again. And now I'm up to 30%. And I don't know if you can notice that, but I can see it here. The Birkeland currents are thinner, and they're no more frequent, but they're just thinner. And as I go up, they're getting a little sparser. And if I go up to, right now I'm at 48%, they are actually, I'm at 50% now, the Birkeland currents are actually not as powerful at 50% duty cycle. Because look at the light now. It's not flashing red or green. It's like in between. So I'm not sucking the maximum current out of here. And I'm at 50% duty cycle. Let that be a lesson. More is not always better. More is not always better. But I suggest that you do not go any higher than 50. I find that 35% duty cycle is more than adequate for just about every frequency I play with. The plasma ball is pretty much confined to working with low audio up to ultrasonic, low ultrasonic. Anything over 20 kilohertz, you're into the ultrasonic range, or you're moving into it anyway. And the plasma ball works very nicely up to about 35 kilohertz, which is certainly more than you and I can hear. It's at the low end of the ultrasonic range. And there's a lot you can do in that area. I find that if I scan the frequency database that is provided with the Spooky, the majority of the frequencies are in the audio range. So what's that tell you? It tells you that somebody had a lot of results or effects that worked for them using frequencies in that range. This does not in any way discredit Spooky Central's new machine. that can modulate a plasma up in the megahertz range. That is its own beast. It can do its own thing. It has its own advantages, and it's, you know, I'm not trying to subtract or take away from that at all. I just want to point out that we have another way of generating a plasma field that generates an electric field, not a magnetic field, but an electric field. A magnetic field is entirely another beast. And the electric field can do a lot of things. And that is exactly what Rife did. I got a blog response saying that no, he was doing, it didn't just do an electric field. You can go look at the blogs to see that response. If it isn't just doing an electric field, what else is it doing? It's not doing scalar waves, because that's not, I know how to generate scalar waves or longitudinal waves. It's not doing that. And if I take my meter and measure with the meter the magnetic field, there's hardly any magnetic field. And I know the difference between magnetic waves. Boy, do I know the difference. This generates magnetic waves. This is a 10-inch toroid, and it's built and designed to conform with the number 9 code, Fibonacci, and the golden mean ratio. There's proportions in here, and this does magic. But this is a magnetic field device. This is an electric field device. And they both have their place. Okay, that's my presentation. And you might have noticed when I was changing frequency and duty cycle and so forth, how I changed and I killed some of the harmonics. It depends what you're doing, what frequency and so forth you're at. If you have a scope when you do this, play with this, you can learn a lot by association. You can see what's happening physically in the ear. I'm getting a visual of the electric field in the ear. And it just works better for me in relating and understanding. To each his own, I guess. So with that, I hope these two videos clarify a few things, give you a basis by which you can build your own. These only take, on a good day, these only take about an hour to an hour. There's always invariably a solder joint that didn't do well, or I reversed the diode or something like that. Remember, I'm an old man, so I don't do things perfect the first time all the time. I used to, but those days are long gone. Okay, so again, I enjoyed doing these videos. I'll put them all together in shortly. Right now, my time, they're not on the internet. They will be on the internet shortly. Have a very nice day, everybody, and I look forward to getting some responses. Okay.